notes. Okay. Okay, now we saw what we wanted to see, and let me check whether I can get that. I cannot get that paper. Okay, let me share that paper here. So my suggestion is take each of them. K means then singular value decomposition, then principal component analysis. At least find 2 papers, right, which will be applying this in some practical application. It can be robot path planning, it can be stock market segmentation, it can be customer segmentation, it can be crop leaf detection, any of the problem, right? Take 2 problems or 2 papers, paper 1 and paper 2, right? So minimum is this, you should get these papers and you should implement and you should write your own JIT. When you show it to somebody, this is what you implemented as a part of machine learning. Rather than writing scikit-learn code and all those things, I prefer to see this because this gives me an insight into really can you appreciate at a higher level or you will copy and paste. When you copy and paste, I would like to see, I will go with B's. Right, they can do it. In masters, some innovation, some kind of leadership is what I'm expecting. So you must lead, you must take, I will do this. Forget about optimization and other things. It must be working. If you can get me the working code, that is enough. We are least bothered about optimized code. Optimized code we will give to programmers. You optimize it. That's your problem. Our problem is to make sure that a working problem, if you give this input, this is the output I'm expecting for known cases, is what is to be done. Right? If you can do this, right? Paper 1 can be customer segmentation. Right? Which we will do. You can read and we can see that. The second paper can be something like robot path planning. Right? Here it can be topic modeling, which we try to cover. Path planning. If robot has to plan its path, right? Can you direct it instead of deep learning? Can you go with K-means? Because deep learning complexity is very high. The K-means complexity is comparatively low. It is ONM, OKNM, where K is number of clusters, N is number of rows, and M is number of columns. So within this complexity, we can find it. If K is less and M is less, it will be ON. Let's say that I would like to go for 1 million records and 5 clusters and 10 columns. So K and M are very small compared to number of records. 10 lakh records, 5 columns or 5 clusters and 10 columns, nothing. Then still it will be ON. Isn't it? Within that time of amount of time it can converge.
Here R is
K and M. Yeah. This is number of clusters.
Okay.
This is number of rows.
Yeah.
Number of columns. Number of rows and number of columns.
Yes.
So if you can get this, it's an approximation. You should not go with this, right? But generally this is it. And if you want to do it in real time, it will be only K calculations. You have to just compute for one row how far it is from K cluster centers and assign it to minimum, done. It is scoring. Quickly it can be done. Anything in real time. So if you look at the deep learning or convolution learning to K-means, K-mean is order of magnitude less than deep learners. Is the quality good? May not be good. Why do you need for a level 2 car, which will be going in a path which is already predefined or it is known? Why do you need deep learning? Level 3, level 4 are required. They may require, there are different types of cars. Level 0, level 1, level 2. Level 0 is ambassador, old ambassador. Right, if you want to start prime it and it will start and all those things is level 0. Everything will be driven by, so level 1 will be some kind of controls, especially if you are seeing Volvo and other buses. If the speed is more, the skid pattern is likely to be there, it applies the brake immediately. ABS kind of thing, right? It can be anything, or it starts the engine, it does something, it controls it. Level 1. Level 2 is most likely parking. I would like to leave automated parking, only for parking. I do not want it to do anything, right? Or in a highway auto cruise. Yeah. So these are level 2. Level 3 will be where engine health monitoring will be done. All those things will be done. Level 4 is autonomous vehicle, where it knows, it takes you. If we are not wishing also, it will pull you and keep you in the car and dump you there. All those things will level 4. But level 4 is questioned today also. There is one US case that is going on against Tesla, that which regulator will give insurance for Tesla cars. They will give for cars for the third party if it meets with accident. In case of human error, it will be around 10 lakhs, a million of compensation. If it is machine which is killing, who should be held responsible? The owner, or Tesla who made that, or the government who did that? Now you define. It cannot be 1 million. It can be at least 10 million. So 10 million for any disfigurement or death, is it likely to happen? It is impossible. So I'm not gung-ho about self-driving cars, autonomous vehicles, industrial autonomous vehicles, absolutely. Right, we want it. A tractor, agricultural tractor. Finding somebody is very difficult. In fact, for one of our farms, we were looking at somebody and he was asking about 30,000 rupees per month. I said, my nephew is getting 30,000 rupees, he's being and AI engineer in Infosys. He's getting 30,000 rupees and a farmer, I mean, he's not even farmer, right? He's a labor and there's nothing wrong asking 30,000 rupees because he knows the time value of money. If you cannot give it, he will take that. Rather, I will invest 3 lakhs on a robot which does this job, give it to somebody else also and do it. And they say it is not correct. That is not the way. That's their problem because everybody has their point of view. Our point of view is he needs food, I will give food. He needs shelter, we will give shelter. He needs money, I cannot give money. It is not need, it is want. Why somebody needs money? There is no need for money. You want to complete education, I will sponsor the education. No, he says give me money. No, I will not give money. I don't have money. We will not give money. That money is the biggest problem. So the problem is that level 4 cars, level 3 cars itself is okay, but level 4 cars are no. Level 5 impossible. We do not want to allow. Right, drones, cars, and other things. Every terrorist will have his own fleet of drones, his fleet of cars, and who controls it? Impossible. We should not do that. So it is unlikely. So if you ask me, K-means is much better than any CNN and other things if it is autonomous vehicles within a restricted path. Right, one such project we are doing in race also, where the vehicle on which we mount the robo or things like that should move around in the race building. You have seen race building 2nd floor and 4th floor, right? There is only a rectangle. Yeah. There is nothing else. It should detect the object and it should decide whether it is human or non-human, how far the human is, and depending on that, it has to move. And that is level 2, level 3, right? But we do not want to go to level 4. And possibly it will speak to you. It will ask, do you have any problem? May I help you, kind of thing. Look at it. If you are interested, get in touch with our team so that you can always work with that, right? So now look at these topics. Topic modeling is another one, right? Topic models, right? So then dimensional reduction, right? So here you can look at stock index or any index. I will show you later what exactly is index, why you would like to take this, and possibly you can look at something like image compression. Now do these things, right? Implement these things and write the blog and see. You have to put that in LinkedIn also. This is what we are doing and this is what I have done. This paper I have implemented. This 6 will give you enough traction, enough visibility. You don't need anything else. And in fact, add to this the additional papers that we are looking at for linear regression and classification. Stock index. So get these papers. These 10 papers is more than sufficient for you to claim anything. But write these papers, publish these papers, put any of these papers as your capstone. Right? With 10% improvement. Some 10% improvement, improve it and do it as your capstone. That's more than sufficient. You don't have to wait till the end of the year to search for capstone. Take any of this, put it. Right? So if it is regression, we are interested in remaining useful life. Right? A machine is likely to fail and I know what is the vibration signal, I know what is the temperature signal, power signal and all those things. I would like to predict how far it is likely to leave with a band of quality. I do not want somehow it is creeping. No, that is not the case. It should not tell me I am drawing, it was supposed to draw 1 ampere of current, now it is drawing 5 ampere current because of the resistance, right? And it should not tell me, oh no, still it is working. That is the Indian attitude. It is not broken. Actually, it is broken. It was supposed to draw 1 ampere of current, it is drawing 5 amperes. It means that there is some problem, right? So look at that energy consumption is a big problem, right? So you can look at remaining useful life, right? And energy prediction. So energy prediction. It can be solar energy, it can be wind energy, it can be thermal energy, it can be residential complex energy requirement. Can you predict how much energy is required for this building? Right, it can be anything. So classification, you can look at malware detection, right? Then risk classification. So just go with these 10 papers, select these 2 papers in each of them, and that's more than sufficient. But the thing is, like we are doing, you should know in and out. You should explain. You should have your blog, right? You should have your paper published. Your code should be available in JIT. Make all these things available. Go for a couple of interviews now itself, and then you know what they ask, how you can control. And that's the feedback. What is that they are asking and all. Along with this, rest of the things you can do. But for me, papers. What paper you have published, what work you have done, how much business value you added. Tell me these 3, you are in. If you say no, tell me what is it. No, that is what I'm asking from you. What business value you add. Show me how much work you have done and what papers you have written. Where is your code? Can you show me those things? Otherwise, rest of the things, no. If you are moving from the mid-career to AI transition, do this. Rest of the things doesn't matter. You have to write the blog. You should not read the blog. You read all the blogs, but write the blog. Right? You have to write the blog. You have to take these 2 papers, improve the papers by 10%. Enough. Yeah. So that should be your goal. In fact, if you can do all of this, because I have kept only these things because we are covering this in LA. Right? You need not to restrict it to this. So you can increase it by deep learning 2 papers. Right? In deep learning, possibly you may be looking at face recognition. Right? Speech classification.
So shall we switch on camera?
All right. Okay. Thank you. given, right? Is visible? Already I sent that image. Okay. Face recognition, then look at reinforcement learning. Reinforcement learning, just go for few more, right? Reinforcement learning, maybe predictive maintenance, and another paper maybe supply chain analytics, right? Then you can look at fuzzy systems. Smart suitcase. Then possibly something like, let's say smart suitcase has been done. Can you control car, vehicle? Right. So this is more than sufficient for you for your entire thing. What my expectation is, you drive it rather than sitting listening all those things. Take these papers, come to the session, you drive the session. Then it makes all the sense. You have to bring the trainer to the knees. That's where the competition is good, and both of us will be learning from each other. You might have done the paper. If you do that paper, I have not implemented any of these papers, maybe except a couple of them. It's customer segmentation, stock index, right? Energy prediction, malware, except few of them I have not implemented all the papers. If you implement the paper in that area, you may be 50% ahead of me. Because of my experience, I'm asked hundreds of questions which you cannot answer. That will not stop you in knowing this paper. Right, for me, you know this paper, you implemented this paper, you are 50% ahead of me. That's what is needed. So I try to go for around 20 papers. If you can implement it over a period of 2 years, you need not have to worry about getting project, waiting for projects and things like that. But choose an area, right? At least 1 or 2 areas. Don't do everything. Do everything, but when you go for a kind of orientation, go for either IoT analytics or financial analytics or engineering applications or customer analytics or enterprise analytics where AI is used. Choose 1 or 2 topic areas. IoT, robotics, maybe one area. They are connected if you are going there. Right? Do most of the projects in those areas. If you need data, we can arrange for the data. Data is not a big problem, right? Doing it, adding some 10% is what is important. Publish it in good journals. Okay. Improving the algorithm, adding new data sets or adding new variables, or possibly looking at it from a different perspective. Now customer segmentation may be looked at, just build 5 segments. You will add by, no, with 5 segments, I'm interested in which segment gave me higher revenue. Right? I will qualify, my correction factor will be revenue, not the sum of squared error. That will be your 10% change that you are adding. Right? Who is giving me more money? So based on that, I would like to align them together. And he must be very recent and all those things, which we will do one project now after the K-means. We will see how it can be done. Right? All the time, try to take these 2 papers, everything that we do, 2 papers and implement them. That will be really good. Right? In fact, this has been adopted from Harvard Business. Our business school is 40 cases, you're an MBA. You solve 40 cases, you're an MBA. And to solve 40 cases, it requires about 160 hours. Right? 160 hours, almost you will be killed. Right? And you have to do within 2 weeks, because every 2 weeks once you have to present a case. You have to participate, you have to do that. The moment we start doing that, by the end of HBR, you know everything, in the sense that confidence to know everything. Right? You may not know 99%, but that 1% you know better than others, that will give you everything. Same thing here. We are reduced it to around 20. Instead of 40 papers, 20 cases, implement them, know them thoroughly, present them, write the papers. Right, you are there.
The simple ones are actually the rank order clustering that you gave. It actually now looks very simple. We started the paper, read a little bit algorithm, what it is. some small piece of code, then little bit extended, that generalized. Now we understand, okay, so this is the problem, this is the way approach, and it gave a much comprehensive understanding of what are the things. Then, okay, some piece of block of code, yeah, is working.
No, never go with that, because if you try to go with the code, you have to remember. Yes. Never remember anything. Yes. It must be principles. You can get everything from Google. There is no need to remember anything. Right? Don't remember. Try to understand the principle and sequence. What is the principle? What is the sequence in which you have to do that? That is more than sufficient. We can always debug. If there is problem, we can download the code. Most of the intelligent editors now throw the error. If you read the error, it will tell what is the problem and fix it. Right? Don't get too much into programming. We are not world-class programmers. Let us not compete with them and say, I want to go to Facebook. Let me compete with the young kid who is just passing out and has studied in IIT. No. We would like to, fight in a flank. If you hit them in the front, no, they can block. If you go behind and hit, nobody knows where he has been hit. Right. So your experience, in fact, they say, no, the strength of the amateur is killed by wiliness of the stalwart. Because he's so cunning, over a period of years, he gets that experience. What goes wrong? He will never do straight. You should not do. If you do things straight, he is amateur. Any professional will try to find the shortcut. Even to write the papers, if you can find a shortcut and publish and improve 10%, you are there. That skill is what you have to get now. Get everything from Google. That's why I always say all my exams are open book. There is nothing, no need to memorize. Right? You copy everything, but it forces you to think. When you have been forced to think, your ability to solve the problems become better. When you are forced to memorize, we are happy. We will memorize or find it tough. Memorization is wrong. Only some, sacred mantra should be memorized and we have to recite. Other than that, nothing, no memorization, just logic. What is the consequence if I do this? Do I know? Conceptually, can I get the code and do it? Right? Okay, let's get into one of the papers which we are interested in. Let's look at that paper. Let me get that. Okay. Morning session, evening session. Let me get inverse exponential k-means is the latest k-means. One of the problems. Okay. So it's a big problem. Can somebody share me that? I cannot connect to this. That paper.
What you said?
Yes, inverse exponential k-means. I cannot open it here.
You want me to bring it up there?
Yes, that would be good. I will stop my sharing.
I will do that.
Let us look at what they are trying to do and then we try to implement.
I'm there, sir. I can share it any moment.
We will read and we will try to see how do we implement. Then we will go for that code. I hope I have the code. Even code you have to share me.
Yeah, I'm sharing.
You have to share. Let me share it.
Unfortunately, the sharing option is disabled for the participant.
Okay, let me go with my own thing.
Who set up this? How can you make present me? Presenter.
I have made you as a presenter. You
can
can share it now. Yeah.
Excuse me, ma'am. You are the coordinator.
Yes, sir. Yes.
Okay, someone has set up the.
You just talk to Joda.
Sir, it is allowing now. No, it is allowing now. I don't know. Yeah.
Yeah, I'll share it.
Yes, sir. I share the PPT.
Let's understand this step by step. Sorry, sent. Bomb. Big problem. You're sharing it with me?
Can I share the.
Okay. I cannot see probably. You had to put it here in the chat box so that I can download and share it here. Both the notebook as well as the paper.
Done, sir. I will send it here the chat. Okay.
Algorithm has its own area.
Application area. Yes.
So, for example, PCA, in image compression, we have to use PCA, but
No, not necessarily. You can use K-means for image compression, PCA for image compression, independent component analysis for image compression, auto encoders for.
can be applied in
Yeah. Basically, dimensionality reduction. When you go for K-means, image compression will be like this, right? You'll have pixels. Right? What K-means does is K-means reduces this to only few. So you have up to, let's say, 760 pixels. That will be reduced to 760 by 1026 to 360 by 625 pixels. It will reduce.
So the column will be same in the
K-means.
So
In PCA, the columns will be reduced. I mean, with minimum columns, you will recreate the image.
so both can be applied.
Both can be applied. Actually, you can apply one after the other. First compress it with PCA, then compress it with K-means. So that will be chaining. That is a paper, right? So I'm doing both, right? I will do PCA first, and then I will do K-means. I will try to recreate and see how many, what kind of cluster is likely to give me better results. What number of principal components is likely to give me better results.
Sir, when you are saying K-means can be applied for this example image compression, let us say we have 760 rows and now it is 360. So 360.
No. It will not be 360, right? It looks like 360. Basically, you have around 2, 3, 5 clusters, right? So each of them belongs to 5 clusters in some way. There are only 5 clusters here. When you say compression, it is not reduction in size. It is reduction in number of records. So it looks like when you take that 360 by 620, if we take this and expand this, it looks like this, right? Some blurring happens. When you do clustering and replot the same image, you can see such kind of blurring. Because all the pixels will not have this intensity of original image. It will have some reduced intensity. If we want to recreate, normally we go for mean kind of histogram. Take the histogram and try to find what is the mean value of this and add it here. So it becomes brighter. Image sharpening. So what we are trying to do is we try to reduce the 760 records into about 5-6 records.
5 to 6 records.
5 to 6 records. You can say 5 to 6, 10 clusters, 10 records, cluster centroids.
Okay.
And you will plot the same image with the cluster center colors. You will not use anything else. It belongs to this cluster, this cluster, this cluster. It will be hazy. For example, let me show you how it looks like. Something wrong. Okay. So K means image compression. So if you look at it, let us look at how the image compression looks like with a paper.
Each cluster will have some dimension, right?
It will have same dimensions.
Same dimension.
1026. The number of columns will be 1026.
Column will be same, but
Rows will be 5 or 6. Clusters will have 5 or 6 columns, whatever you specify.
Okay.
If you say K means is 5 clusters, it will have only 5 columns.
So in your example, 10 means it will have
10 rows, 1026 columns. Look at this. Can you differentiate the quality between this and this?
yes, it is blur.
It is blur. Right now you can see how this is one segment, this is another segment, this is another segment, right? So I'm plotting only the segments here. I'm not plotting the original image.
So
Now,
are you sharing
you
your screen?
take the neighboring things, right, and try to see what color this should be. Then you will get the original image. So this is called as K-means transform. The reverse is called as inverse transform.
But how this compressed image will be used? Let us say we have 5.
Now this is 10 MB. You're taking only 5 records.
But
it will be so small, right? It's a lossy compression.
if you take only one cluster, then it's a lossy compression, right?
Yes.
But if you take all the 10.
No, not one cluster. You take all 10 clusters. You will create this image and send. This image will be smaller than this image.
Okay.
You take this image. Let's say this is 1 MB. This may be somewhere around 0.4 MB.
But how this compressed image is created?
Compression image is created at every pixel. I would like to see to which, because if you look at it, all of this will be taken. This is 1026 by 760. This 1026, one of the cluster is there. It belongs to one of the clusters. So that cluster centroid will be plotted here. If you see all these cluster colors, centroid colors, the centroid value, that will be plotted here. So I don't plot exactly the color because every pixel here is unique. Now what I'm trying to do, convert all of them into one value. Not unique value. This pixel, this pixel, this pixel, this pixel. This may be 200, this may be 201, this may be 207, this may be 195. Now all of them will become somewhere like in this, depending on the system's computation how we are taking. This may all up to here it may be 195. There is no color difference. So you're not having anything. When you compress it, all of them will become just 195, 195, 195 RGB. So everything is compressed because you need not have to store more data here. I'll be storing row number 1 is cluster number 1. Row number 2 is cluster number 3. Row number 3 is cluster number 4. I'm just mentioning which particular row because 1026 column remains same in the cluster also. I will take row and its corresponding cluster. So I will send only the row ID and cluster ID, and you can recreate that using the cluster information. Plot it. Once you plot the cluster information, you will get that. Right? In fact, I can show that here. I cannot show that. Anyway, I will show it later. How you can do that. You can compress the image, you can detect, you can basically, we call it as masking. You can mask the object of interest, you can do all those things. Right?
So the sharing is
Sir, are you sharing your screen?
not working.
Okay,
It
okay.
is not allowing us to share files.
No
from
problem. It is not allowing me to look at.
And sir, I've shared the document in the previous
No,
chat.
it's so finding difficult.
That is some problem.
I'll share it. I'll share it. No problem.
Sir, I have shared the Python code and the PDF in the previous chat. Hello.
No, I'm not able to open that.
Hello, sir. Can you hear me?
Yes, got it now. It's the storage problem. Okay, let me take the inverse k-means. Right? Basically, what they are talking about is when we go for k-means, there is a very possibility that it converges on local optima. It means that it will not select 1, 2, 3. Anything that is within that, which is the minimum, it will look at that. It is not go for global minimum. Screen is not shared. So one of the problems that we face in case of k-means is convergence on local optimum. Why? Because the number of centers it has to try is exponentially huge. So that's why randomly which is selected, only for that random, if there is a possibility, it will converge on that. But if there are 5 points which are having the same distance, randomly it selects that. Right? So it is local optimum. It is not global optimum. Right? I don't know from higher level. So what they would like to do is tendency to convert to a local rather than a global optimum. So the way to reduce this, right? So normally they will restart from different cluster centers, right? If you see scikit-learn says that how do you want to initialize? Initialize with random restarts, number of iterations, right? How many times you would like to run this again and again and again? How many starts you would like to have? Or possibly k-means plus plus. Right, these are the few methods that are available. Now, what they are trying to do is there is a method called self-organizing maps in neural networks. Right, they try to maintain the topography. Topography basically means my neighbor is most likely to build home similar to me. Because most of the town planning and things like that, if there is a 60-40 site, the next site is also 60-40 site. It need not have to be 30-20 site. Unless there is a division and somehow government is closing the eyes, there is a very possibility that it will be 60-40 site. Right? So in that case, there is a very possibility that topography of the division is maintained. Otherwise, what happens? In fact, we say some kind of cities like Jaipur, at least in India, and like Venice and all those cities, they have very strict control of what kind of paint you can apply, what kind of rework you can do on your home, and all those things are very strict. In India, it is not. In India, we have too many local optimums. There is a global optimum. You can have this color as long as you do anything, as long as the color of the outside home is pink. You are okay in Jaipur. Right, pink city, pink color, okay. Anything else is not allowed. You cannot go and say, no, I don't like it. I want to do it in green. It's not allowed. Right? So that becomes a global optimum. So we would like to find that topography is maintained. That can be maintained with some methods. Right? Also, it says that initialization dependent. Most of them are initialization dependent. If I start with 1, 2, 3, it tries to converge only in that. It will not check other things. So these are the three problems. The first is local optimum. This is because of number of starts. We would like to go with that. Right. Second is basically initialization dependent. Right. Initialization dependent. So it depends on the initialization. These are some of the problems that we have. And topology preserving manifolds. Topology basically means one which is similar to the other record, they must flock together. The birds of the same feather should flock together. So if there is a method by which it can be done, it's very easy. This is the latest k-means, which is called as the inverse k-means, right? So you can read this paper in detail. What they are trying to do, let us read that. If you read this paper, what it does is standard exploratory algorithm for identifying structure. We would like to identify what is the structure, how records are aligned with each other. If I want to see only 5 segments, how the structure looks like. If I want to see 10 segments, how the structure looks like. K-means helps to identify such kind of structures in the data. Right? Actually, when we explore this, the segment itself is exploratory and confirmatory. Confirmatory means supervised learning. I will try to create the clusters here. I will take each record R1, R2 with V1, V2, V3. Then I would like to add cluster number 1, 2 like this, Rn 3. Now I have this data. This data I can use this variable to predict to which cluster it belongs to. I can use a naive Bayesian algorithm, a KNN algorithm, a neural network algorithm, logistic regression, decision tree, random forest, any algorithm. Use V1, V2, V3, label is cluster. And this is called as exploitable k-means. This itself can be a net or it can be extended. Right? So if you look at that, the problem is depending on the initial points selected for prototypes, it may find a local optimum. That is the biggest problem. Right? So this next problem, soft k-means, which is fuzzy c-means, it tries to align, but the problem is computationally very expensive because it assumes there is a possibility that one point may belong to multiple sectors. Right. Normally it happens. I don't know. You have seen, at least we are seen in the nearby borders in Karnataka. You just go near Chamarajanagar, those people will speak Tamil, Kannada fluently. You go near Ballari, they speak Telugu and Kannada fluently. You go near Bidar, Gulbarga and other things, they speak Marathi, Hindi, Kannada fluently. Right? So the problem there is they belong to Karnataka, but they can be looked at, they belong to Maharashtra also, they belong to Telangana also, they belong to Andhra Pradesh also, Tamil Nadu also, Kerala also. Right? It means the person can belong to multiple things at the same time. That is called as soft clustering. soft clustering. Fuzzy C means soft clustering. Hard clustering means you will put a condition, you can belong to one of the parties. So most of us are, soft clustering participants because we don't care for the party, we care for the, candidate who is standing there. If he is good, even if he is independent, we will vote him. He may lose the election, that's a different thing. Not based on caste, not based on a party, we don't vote him. Right? Some of us are, we don't care. But some, they belong to, okay, if this is from this party and he is belong to my caste, I will vote him. Otherwise, I won't. I will not go to voting at all. Right? It is ridiculous. Bangalore has got only 61% voting. With such a kind of education, opportunity and all those things, it's not good. It means that either you cannot blame the voters because somebody said nota is wrong. You should not put nota. Then don't put nota there.
61% maybe because we are not there to vote. We are not at the place.
No, on the salary day, if the salary is given, wherever he is, he will call. Same applies for our governance, right? What we are trying to do is we are giving it to an idiot.
No, but for me, let us say like I am belong to that and now I am here. How can I vote?
No. The registered voters. It is not the population of Bangalore.
Even I am registered.
If you are registered in Bangalore, if you are in Jharkhand, you should come and vote. That is essential, right? That is my right. We should do. Otherwise, on leaves we'll go. No, that shows the education is corrupting people. Right. That is the reason we are trying to. Normally, it happens, no. In the area of blind, a person with only one eye is the king. Right. When people like you won't vote, idiots will get selected. And most of us, we have such kind of people only. I really have not seen what is the India's vision since last 75 years. Right, they will do once in 5 years. After 5 years, I don't know. Right, that is not correct, right? So basically, we should have the vision. For us, vision is India is independent without anybody, we can leave. If we can achieve that and anybody comes, we will hit them so bad that they should not even dream of. In fact, nobody comes to us except some rogue states in the nearby borders. Nobody else wants to. Why US has to come here and fight with us? Why Russia has to come and fight with us? Why Japan has to come and fight with us? Right? There is no need. So where is that? That is not happening. Always we depend on outsiders. We'll prepare IITians and send them abroad. You enjoy there. Right? But all our people who pay tax, you use that. These are all the things which we have to ask. No, we are not asking. That's the major problem. That's one of the reasons we want the education to be free. Why are you taking IIT? You allow me to take the IIT exam. If I pass, tell me I'm also an IIT graduate. Why do you say I had to stay there for so many years, train them and then send them out? People don't like it because if education is free, where the money is? Money is in engineering colleges, money is in medical colleges. So how can it change? We cannot change. Do you need a PhD for learning XY? Is not needed. Skill and other things can be developed independently. So I disagree with that. Probably you may disagree with me. That's not a problem. But I vote. Right? Even if it's an idiot, I would like to see best of the idiots we will vote. What do you do? Okay. So now, if you look at it, in case of the proposed algorithm, what they are trying to do is they are trying to use the distance in terms of a hat function like this. A hat function like this. A hat function like this. This is minus, this is minus, this is plus. It means that if it is within this boundary, which is given by this equation, I will try to assign it to you. Not minimum distance. Right? It is minimum with some kind of cutoff also. They are trying to give cutoff on both the sides. And this is called as the Mexican hat function and things like that, which is given here. Right? So once they do it, they are showing how exactly this is the data set they are taking, 4 clusters. Right? And we already know there are 4 clusters. And can the topology be, you start with these 4 clusters and go around and do that, who exactly they are trying to do, right? They implement the distance as minimum, like what we are doing, but some kind of exponential value which is trying to give us this exponential value is what they are trying to do. Now we asked why I should go for our own method. So this is not applicable in case of a scikit-learn algorithm because this becomes 3. This is 3 now. Now what we have done 1 and 2. A square distance or a Jacobian distance or a city block distance or a Manhattan distance is what we have done. Here is a power distance, it is 3. Right? Now if you want to do that, I have to write our own algorithm. We'll do only for 2, but you can extend it for 3. Now he has extended it for 3. Now you can check, can you make it elliptical? What happens if you make it elliptical, right? Whether there is a possibility. What kind of data set needs elliptical kind of algorithm? Here we will go only with the exponential raising with second power only to the power of 2, right? So we'll see what exactly we are trying to do, right? Then they try to give, right, all computations will be given, right? So it tells me what is the computation. Now it says that don't worry about all these things, how they are deriving, right? Delta jj by delta mj equal to 0, minimize all those things. This is nothing but the minimization of the differential equation. You take any equation, differentiate it, assign it to 0 and solve the problem, you get it, right? You get the roots of the equation. Don't worry about all those things. What we have to implement is only this. Right, we will be implementing only this. Mapping 1, mapping 2. Right, we will be implementing only this. This is very easy for me to implement. Right, some gamma multiplied with gamma is some factor. We will see gamma beta or gamma this factor multiplied with square distance. Right, divide by these two, we will get it. Basically, if you see the effect of exponentiation is to detect these 2 points. Otherwise, it is same as k-means. So what they are proving is this preserves the topology. The similarity of the records is better preserved in this algorithm than previous k-means algorithms. Currently, as of now, this is not implemented in scikit-learn. So you can implement this. You can implement this, but when you implement this, it must be according to scikit-learn standards. Right? If you can do, there is nothing wrong with that. Yeah. So he gives how exactly it has been done, and you have done it on multiple data sets, right? And they prove, right? We have shown it can be overcome by global information with artificial data sets and some real data sets like iris, right? Please read the paper, but let's get on to how exactly this will be done, right? Let me try to open this. I don't know whether we have. No, Nakunda. Okay, better not to try this system. I will use my system. Just give me a minute. I will shift my system. Okay. So we'll start with importing our numpy, and then we will import the pie plot because we would like to plot it, right? Now, if you look at it, the second function that we would like to write
Sure.
is basically I would like to find the difference between two vectors, right? I will send u, I will send v. U minus v is what I would like to get as return. We did this as matrix subtraction, vector subtraction. Right? So what I will pass my u and v, right? Then I will get the delta and I will try to send delta back delta. Basically, it is square distance of what we have found with sigma. We found this, right? Data delta in data, right? So it sends me the square distance of whatever we are getting.
So share this.
Not there at all. Okay. So AI04 meeting. Friday, Saturday, nothing. You just share me the link. I don't know whether they have my team ID. Everybody except trainer has this.
It's in the chat also. Link.
I mean, already I sent it. Okay, thanks, man. Thank you. Okay. It's visible now. So let me share my screen. Thank you.
Maybe can stop
Thank you.
sharing from the other.
Yes, I'll close that. Okay. So let me open up the paper and we will look at the paper. So this is the paper. After the paper, we would like to look at the algorithm, right? So now I would like to take my square distance of the error. So once I do this, I would like to understand what is the cost, right? Basically, cost of doing it is nothing but X. My X actually is my original data set. This data set, this is X. This is X, right? Now R, I would like to find the R. Basically, I would like to say I'm passing R here. So if you look at it, R will be passed as NP of zeros, right? It's a restrictive matrix which starts with NP of zeros, where K is number of clusters and N is number of records, right? What I'm trying to do is N 1, 2, 3 up to N and K 1, 2, 3 up to K, right? This is what I'm creating as my R. It's a buffer matrix which I would like to use for computing the cost. right? I have the original matrix. I have the K matrix. K matrix, this is nothing but the K matrix, right? In between K matrix, I have n records and K kind of clusters. I'd like to see what is the cost of assigning it to each of them, right? If it is hard K means what happens? This will be 1, all others will be 0, because it can belong to only one cluster because of the rule. Whichever is the minimum, assign it to it. It will not tell me, it is not maximization of the minimization of the distance, rather it's a kind of whichever is minimum, winner takes all. Whoever is minimum, it takes all, right? If there's a tie, random selection. So that problem is avoided when we try to have what is for each of them, how much is the membership, right? So we will compute that, and after adding all these things, right, we would like to again get the square distance, right, on axis 1. Axis 1 is my columns. On each column, I would like to get the distance. For every column, I would like to get the difference. Distance, difference into difference, because difference already I'm computing here. I'm computing the difference. This difference, I would like to apply the difference everywhere for every column, because axis 0 is my records, axis 1 are my columns. Right? Axis 1 is always columns, axis 0 is always the rows. Right? On axis 1, I would like to apply this.
Sir, what is actually U and V here?
U and V are some matrices. You send some matrix and it will send you the square
But
distance.
in our data, what we are sending, are we sending U as one column and V as another column?
Yes. Yes. So if you look at it, that's what we are trying to do here. Right? So when we try to find this, we'll be getting all of them. And if you can see this reference, this MK, I'm sending one, right? XN, I'm sending another. So basically I'm sending this and this, one of this column and one of K columns. So I'm taking the same thing, N and K. Right, I'm sending two columns, right? Two difference. Difference takes two columns. Right, so I'm sending two columns here, and I'm trying to get this beta difference which has been computed here. Right, in my paper. This is the paper. Oh. This is what we are trying to do here. We are trying to do here. So once I do this, exponential to the power of this divided by, I find exponential, then divided by sum of exponential. So if you can read this, so it says that exponential divided by sum of exponential. I will take the exponential value of given column and divide it by sum of exponential. Add all of them. Basically what I'm trying to do is, what is the distance? This gives me maximum. I will take all of them, right? For these two columns what it is, and for all the columns what it is. I will take all the columns. Now take only this column. This is sum. And exponential of the sum and exponential of this column divided by this and divide this by this. So this gives me this kind of patterns. So once I have that, I would like to use, in fact, as I told you, I'm looking only at this. How can I implement this? Rest of the things you can always read, you can go deeper, but is it implementable? Can you implement this? No, you cannot implement this. For example, you cannot implement any of this. It is just to prove what is implementable is, at the end of the day, if we read it, this is the only thing that we are going to implement. That's the only thing that we are going to implement. So once we do that implementation, we would like to map it. We can see this mapping, right? I will try to find the R, then M, the full vectorization. What exactly I would like to see? I'd like to see how my M can be done. I have done for each of them I have done. Then I would like to compute it using R. So I'm getting R from these equations and I would like to compute my M with R. So this equation is also there. So once we do this, I will send the cost. Cost function is computed here. Right? So I will send this, and when you see this, I'm getting cost. Now I would like to generate some simple data. In fact, simple data generation is nothing but a random function, right? Add the data. So here what I'm trying to do is first create the array, right? Then try to add some 300 points, right? 0 to 300 will be one cluster, 300 to 600 will 301 to 600 will be another cluster, 600 to 900 will be another cluster. Right? I exactly know 3 clusters are there and I will get the data. Once I get the data, I will try to plot the data because now I am having only 3 columns. I can do it for 2 columns. Let me see whether it can do for 2 columns only. I will do only for 2 columns now because we will do it only for 2 columns. We will not do for 3, right? We will do only for 2 columns and we will see how it looks like. Once I plot this, I know without clustering, I know this is cluster 1, this is cluster 2, this is cluster 3. Right? Now, I would like to run my k-means, right, which are written here. Right? This is my k-means. When I run my k-means, I will get some feedback. Right? It gives me M and R array. It is returning M and R. R is nothing but the intermediate matrix. M actually is the membership matrix. Right, it's in my membership matrix and the R matrix. So once I get this beta, I can set what is the value of beta. So if you read this paper, it talks about the data, gamma here. I can set any point. Right now I am setting 1 because I would like to write it as k means with square distance. So you can change this. It can become 3, it can become 4, it can become 5, doesn't matter. Right? So you can make those changes. So once I do this, I would like to create all of them. Then I would like to create the M matrix, which is nothing but membership matrix. Right? Where is the cluster center? So now if you see this, the 3 cluster centers are detected 1, 2, and 3. Right? Now you can start with where it has been randomized. Now we can come down and we can start with initialize the cluster centers. Right? When we initialize the cluster centers, I'm using random choice. Random choice means so many n. N is nothing but number of records. K is nothing but how many are to be taken. When you say replace false, it means that you select only K records from n records that are available and don't replace them. Because sampling can happen in 2 ways. Sampling with replacement, sampling without replacement. When do we use sampling with replacement? When you want to increase a small data into big data, we try to use sampling with replacement. For example, in some cases we had around 300 data points, but actually for running the deep learning, we wanted to have somewhere around 30,000 points. What we did with replacement, right? Do the replacement sample, do the replacement sample. Basically replacement with sample with replacement is you have a bucket of balls, you take a ball, put the print of it, then put it back. Next time it may come, it may not come, but do it 30,000 times, you got the sampling with replacement. Yeah. The second is sampling without replacement. When do we do that? When we try to, when large set is there, when we want to reduce the size, right? Instead of doing clustering, we can do sampling. Right? There is an approach called as Simha. You have to read this, right? For building machine learning and statistical models, this method can be used. It is called as Simha. Simha stands for sampling. The first thing is sampling. Any pattern that is not available in sample is unlikely to be available in the big data. If somebody is trying to find some pattern with means and averages and things like that, no, that is not good. Right? Sampling is the way. If you can explain your 100% with 10% sample, it is good data. That's where we say that quality of your data is good. But if you need big data, because wherever I go for consulting, that is one of the problem I face. They say that I have big data, what to do? I say you take sample and see whether the sample also tells the same thing about your big data. If not, the quality of your data is not good. If the sample and the big data are telling the same thing, let us say that you take a sample of 10,000 records, and out of this you take 100 records, right? If the average here is 20, the average here is 19.8. Good. The quality of information your data contains is consistent, right? Now, if this is 0.5 and another one is 1.7, another is 37, you take multiple samples, all of them are showing certain things, then actually your data quality is not good. Not data quality in the sense that missing records are there, nothing like that. The predictive information that is there in our data is less. Because for any AI, the system should be predictable. If the system is not predictable, you cannot use AI. AI is good in a steady state system. If the system is not in steady state, you should not use machine learning, AI and all those things. Right? When it is in transient state, you should not apply it. Somebody comes and purchases something from you. First day you cannot tell who is he. Right? It's very difficult. But after 6 months, what he purchases, what he is doing, based on that you can predict what he will do for next 1 month. You have 36 months, you can tell for next 6 months. But with 1 day you cannot tell anything. Up to 6 months it is transient state, it is not steady state. After 6 months it is steady state. Expectation is you have to participate. If you are not participating, I know how many people in the past who came within 6 months, after 6 months they are not transacting anything with me. I know what is their behavior. We can find that. A machine which has just I got the machine, I cannot apply predictive maintenance on that. I need at least 3 months of data for that machine. Once I have 3 months of data, I know is there any deviation in the parameters I am selecting. I am measuring certain parameters at second level. Is the parameter constant or parameter change? Even this is deviation. Based on the time, it has not happened here, it has not happened here, it has not happened here, it is stable here. That is predicting the anomaly. Predicting the anomaly is the most difficult thing. You can use k-means for doing that. Right? So when we do, the random choice will tell me what are the initial centers. So I will get the initial centers and I will loop through them. Right? Once I loop through, I will get the minimum of them. Right? Find minimum cost and append it. I will get my C and C means, and once I get this, I can plot this. Right? I'll share this. Probably you can run this. Then we will go for implementing this as a project. I shared one data called RFMPT. You can check that. Right? Using that data, we will see how we can do this. Yeah, let me see where is that data. You can open up your notebook. We'll run through this due to shortage of time. Otherwise, we would have gone step by step like we did with k-means. But my suggestion is open it up and start from here. Go to k-means, right? And take each of them. So now you know what is x, right? My x is given as this is my x, right? This is my x, right? Now go here and implement what is NDX shape. Now let me show what exactly I want you to do, right? I will use this. I will use this get simple data. We'll use this in a different file because I do not want to. Ta-da-da, new notebook. I had to write simple data, get simple data. So I had to define simple data. Then I had to call this function and return x. Now I will take x. Right, I will run this. It is running. Now I would like to say x is equal to this. Right. get simple data. So now it has been done, X has been done, right? So NP is not defined. Let us get NP. Port numpy as NP. So when I got this, right now I can implement this. mu1, mu2, mu3. I got the error. Error is we reduced it to 2. Actually, we said dimension is equal to 3. This is the problem, right? So now we would like to change this to 2. Right now we have the 2 and I would like to change it here. The number of dimensions that I would like to use will be 2. Right now I would like to get this. Right now I would like to see from my k-means what is that I would like to see here. The first thing I would like to do is ND. So ND is what I would like to take and I will implement ND here and I will print N and see what it is. My N looks like this. There are 900 records, right? My D should be add and D, right? Now let us look at D. Right? N and D. I'm getting how many records and how many columns I got it. So that's how you will be deconstructing everything. Now I would like to initialize R is equal to NP zeros. Right? Now let us put R is equal to NP zeros. Right? It's been done. K is equal to 3. Right? Let's assume K is equal to 3. K is equal to 3. Right now let us look at R, print R, how it looks like. Now if we look at it, right, so how many are there? Basically n rows are there, k columns are there, 3 columns are there and 900 rows are there. So you can look at shape. Right, 900 rows are there, 3 columns are there. Right, so now let us take the next one. So you will initialize this. Right, you will initialize the cluster centers. Now I know what is my n, what is my, right? So I will initialize my centers. Right now I would like to say after this, right, I would like to add, I will select what are these centers. Before that, let me select what are my initial centers. Initial centers. What are my initial centers? It will be an array. 351, 72, 512. Record number 351, record number 72 and record number 512 are my 3 records that have been randomly selected. Right? In the choice I had given, out of 900 records, select 3 records without replacement. And it has selected these 3 records. Now, these 3 records will be used as the cluster centers. 3 records, 3 columns is what we are looking at. Now I would like to go with M is equal to this. So M has been initialized. These are the cluster centers. Now I would like to see M. What are the cluster centers?
Sir,
Yeah.
so we were looking at 2 columns, right?
Yes.
Yeah.
These are
No, are we
3
considering?
3 clusters. Number of K is
Okay.
3. K is equal to 3, right? We know there are 3 clusters.
Dimension.
Yeah. So
Okay.
we know 3 clusters.
Okay.
So let me plot this. We have 3 clusters. Right. Now let us say I would like to plot this. Let me take this and plot it. Right. So we'll plot this. So we'll get this after this N and D and all those things. D has been shown. Now we will go with adding code and we'll present it. So if you see what is needed, PLT, matplotlib. Right now we are showing there are three clusters, three possible clusters and two dimensions, two columns, right? So once I get this, right, now I would like to look for which are these centers, right? Now let me plot this with my cluster centers. My revised cluster centers are this, right? I randomly selected the clusters and now I would like to see how my cluster center looks like. This is my new cluster center because I randomly selected them. Now I would like to see, right? One is here, another is here. Actually, one of these should move here. That is the process that is likely to happen. Right? Whatever we have done earlier, we can see the same thing is happening here. Right? So now once I do this, I would like to repeat what we have repeated in univariate analysis. Find the distance, right? Instead of finding the distance, we go for inverse exponential algorithm. We are not using direct the cosine, Euclidean distance based algorithm. We are going for exponential, inverse exponential algorithm, right? What that algorithm does. Now let us look at what that algorithm does. How do we move about getting this? So after this, I'll be taking cost as nothing. It's a null list. Then we would like to go for assigning k is equal to 0 and maximum iterations like we did. So we are setting maximum iterations. Then we would like to find exponents. For exponents, we would like to see the difference. Now I have computed, I know what is MK, right? My M is nothing but cluster centers. 3 records, 2 columns is my M. Right? X is my original data. I have my original data and I have M now. So I had my X, right? Now I have my M. M is nothing but randomly selected records. Randomly selected records. What is X? Original data. Original data and randomly selected records. For each of k in range k, capital K is number of clusters. 0, 1, 2, right? And for n in range n, n basically is here, number of records, number of rows, right? For all of them, I would like to find what is nk. So exponential nk, I would like to find it, and once we do this, we would like to get what is exponents divided by exponent sum. Basically means it is like when you say df divided by df max. Have you done this? Have you done this in your pandas, in your machine learning? This is one way of standardization. When you standardize this, what you are trying to do is you are trying to take individual columns, right? Divide it by maximum of that column, right? The shortcut is this. You can select column by column what is it, and column by column you can do L apply and write lambda, or you can directly go for this. Right? What they have done is directly they have gone for this. Take all exponents. Exponents is my data frame. For each of the column, sum of that column divided by that. That gives me to which cluster it belongs to. This is nothing but intermediate matrix. So R is my intermediate matrix. right? So once I get the intermediate matrix, I will get the cost matrix. Cost matrix is nothing but how exactly I would like to find the cost, because this assigns me to which it belong to, which segment it belongs to, this M, once I vectorize it, right? If you want cost, you can get the cost or you can drop the cost. It is not necessary that we have to get the cost. Cost is needed when you want to identify what is important for you. Otherwise, cost is not needed. You need not have to compute cost. You can stop at this because that is what we have done in univariate. Right? In univariate, we have found the new cluster centers. Right? For each of them, we found the square distance. Instead of square distance, we are finding inverse exponential difference and assigning it to the minimum one. Right? So once I keep this is needed, not needed, that's okay. But I would like to send M and R back. So my M and R is done again and again. So once it is done, I get M and R. R is not much important to me, but I will implement M. M is of more interest to me. This is my new cluster center. So my new cluster center is like this, right? My final cluster center, I have started with this cluster center. I started with this cluster center. Finally, I arrived at this cluster center. After looping through everything, I arrive at these cluster centers because it satisfies three conditions: number of iterations, epsilon, and no points moving out. Right? After those things, we get these three cluster centers. Yeah. Okay. Please.
See, in this paper, the criteria that they are using for selecting the reassignment cluster, that may be slightly different. If you go back to the original single column analysis, how do we approach the problem? So let's do a double column analysis.
Okay,
if
just
you have to understand that, then
okay, that's not difficult. Now let us look at. I have my.
Here, then if you understand that, then here only will have to change the formula.
Now I have my x, right?
Yes.
I have my x and I have my m, right?
Yes,
I have my m and I have my x.
Data, M will be randomly
Selected cluster records. Now I would like to find the square distance between these two.
Only, there you have some 800, 900. Here you have 3.
Yes. Right. Now let me go for x minus m. How can I do x minus m?
Yeah.
Right. For row in, right? For row in my x, print row. Well, now you are printing each of the rows.
Yes.
Right? Whatever the row that's available, you print each of the rows.
Yes.
Right? Now, I would like to take this. My row is available now. Now, what I would like to do, for every record in the cluster M, I would like to print it. Right? Now, for cluster or CC in M, print right. Now you can see for everything it prints three things. For every record which is there in X, right? Yes. This is my X. This is my X. And this is my M. Yes. Right? Number of columns is equal to number of columns. Right. In X and M. For every row in X, for every row in X, yes. Where is it? For every row in X, I am printing for every row in M. I am printing this. Now what I have to do? I have to take this row. Yeah, how do we? Right? Now I know every row here. Find this minus this. Right? Now let us look at.
So we will look at value 1, value 2. of row 1 corresponding to value 1, value 2 of the cluster.
Yes.
We look at the difference.
Difference.
So instead of having one variable, we are having two symmetric.
Right, now let us compute it here, right? Instead of just printing it, let us print what is the difference, right? Difference is equal to absolute, or let us say CC minus rho, right? Print difference. Print the difference. Now we can see it is printing difference. I mean, for all the 900 records, 900 into 3, 2700 possibilities.
Okay, you will first take the first cluster and take the each one of the row and then print the difference. Then go to the second cluster, print each one difference.
No. First go to first row here.
First row.
For each of the rows here in M, yeah, find the difference.
Okay.
Right, print it. Again, go to the next one. Find the difference. Print it. Go to the next row. Find the difference. Print it.
You get 900, 900, 900. You are getting 3 like that.
900. Right, for every record we get 300.
So it's the same approach, whether it is single column or a
doesn't matter.
So column by column differences you are seeing.
We see only column by columns, then we will sum it up. So what we are trying to do is we are trying to sum all of them. We are trying to sum all of them.
The differences.
Differences.
Okay.
Right. So once we do that, this exactly instead of doing inverse, we have to do Euclidean distance. That's all. So we will write the Euclidean distance. We'll break for a coffee. When you are back, we will write this. Then you can go through the inverse one. Right. Inverse one, why I have selected is I wanted you to implement with 3. Okay. Instead of 2, if you can implement with 3, yeah, I know 10% improvement.
But the approach will still be same. 3 columns are
there. Only the power changes instead of.
Is okay, sir. Actually, that I feel that's probably one function to replace. But approach wise,
no change in approach.
2 columns, 3 columns,
n columns doesn't matter. Right, it doesn't matter. What we are interested in is at what level of power the compression is better. That is the thing that we would like to see because they are not experimented with that. Right. That is why 10% improvement for that paper. You implement that paper, then trying to increase it by or improve it by another 5%. So you are checking what is the best M. Normally we recommend M, right? What is the exponent that is to be given? What is the beta value that is good? Right, this experiment.
Them all together in that,
yes.
For the 3.
Normally we try to use publicly available data and see for most of the publicly available data, the gamma value of 1 and power value of 2 will give Euclidean distance similar to k-means. When we try to go for higher value of exponent, that is power, it changes. What is the best one which will give compact clusters? What is a compact cluster? Where the sum of squared error is less. If I make it 1, will the SSE becomes less?
So if you go to the picture, the cluster picture.
Or this one, huh?
Anyone is fine. So the optimal meaning the dots may move somewhere here and there.
Yes. Yes.
Okay. So that the red dot actually represents the
center of the cluster.
Center of all those.
This cluster represented by this dot.
So how closely you move that?
What is the variance of this point with respect to this, with this point with respect to this? You take sum of all the errors and average it. Should be minimum. Whether I put it here, whether I put it here, whether I put it here, under what conditions it will be minimum is what I am looking at.
So one algorithm gives MSC of some 10 and the other gives 15. The 10 is a better one. And we are trying to optimize the algorithm to give me this 10 or 5 or even low.
Low and find
beyond which it may become unstable.
Not unstable, it is not good. It is not unstable. This is not unstable because this is local.
If you put it so small at 0.1.
Not necessary. It is not convergence. It is not convergence. It is a sum squared error. We are not minimizing the difference between two cluster centers. We will stop the iteration, right? But our intention is to maximize the value that we can get out of it. So that is possible when the sum squared error is minimum. Whether it is for this cluster center, if I try to say that now it has selected some cluster centers like this, right? It has selected which are the cluster centers it has selected. It has selected 351. If I give it as 1, 5 and 500, will it be same? Right? But this algorithm says that you start from anywhere, it will be same. You do it with k-means, it says I don't know. When you start from multiple points, I cannot guarantee you the same result.
I see.
Right? That's what k-means says. What this algorithm says, give me from anywhere, I will give the same result.
So eventually you can optimize the result which I'm putting wherever I start from.
Yes. Yes. So
K means okay, if you start here, this may be an optimal solution. If you start from elsewhere, I may arrive at some here and stop.
It is better than random solution. That's all. K means you are trying to see, is it better than randomly selected solution? Certainly K means is better than random solution. K means sometimes is better than domain solution. But this paper, they are talking about a global optimum, which says that you give in any way, I will bring you to the bottom or take you to the top. Yes. Yeah. Okay, team will break for some time. When we are back, we will cover the other two also, right? After this, maybe SVD and PCA. Yeah. Okay.
This will also, we will read the paper and probably go through the code. I'm sure we'll be.
Takes time because what you had for univariate, you had to have that intuition.
Yes.
How it is working. The moment you get the intuition, it becomes easier.
Do you think if there is multiple columns, then the point somewhere you keep and then do a difference? So we're still taking column by column. Take the difference.
If you know one variable, you know for all variables.
I see. The approach is the same.
Same, no difference. What these people are doing is the global optimum may not be good, but you want to add cost. What is the cost of misplacing them into another cluster? Their computing cost. But cost is not necessary for us. Yeah, please continue.
எனக்கு ஒன்றும் அடிக்கல.
the data points will vary, correct?
Correct.
Huh.
Yeah, ma'am.
Is it in that sense?
Yeah, what is your question?
No, question is,
Oh.
some
We're back in action. Okay. So let us try to understand how exactly we can apply this. If you want to look at some data, I would like to upload some data. For example, if you look at this data, which I shared with you, is there anything? Linear algebra, session 3.
Is it unmuted? Because I muted.
No, I'm not muted. It is unmuted. Yes, it is unmuted. So I'm sharing. Okay. So let me see what the data is. Let me look at the data. I will take this data and I will upload this data. We will see how we can. Right now, if you see this data, this is about the customers. Basically, this data contains few variables which are about the behavior, right? If you look at recency, how recently he came to my stores, right? How many days since he came to my store? That's one of the important things. What do you expect? If you run a store, how do you want the customers to come to your store? How recently he has come? How recently you want him to come? Right? Tomorrow you should come today. Day after tomorrow you should come tomorrow. Right? That is the ideal thing. But now in this case, if you see, it's about 1,167, which is almost 3 years.
The last visit,
Right? What the hell the managers and others were doing not looking at this? The moment somebody comes in, why are you not holding them back? Right? All companies have this problem. They are not looked at it. The second thing is frequency. This I can understand. Somebody who has come only once, he will not come again. Right? This may become in 2000 days. Right? But somebody who has come more than twice, but still his data 16 times, right? Not 16 times, 3 times he has come, 556. It is not acceptable. It is more than 1 year. I want him to visit every 6 months once. He has to come to my store, take something. Right? Now I would like to see how can I do this. For this, I would like to see how many segments are possible with this data. He has visited recently. He is a frequent customer. He gives some money to me. There is some monetary value. He gives some money to me. And he is my customer since 10 years, 12 years, whatever the time that is. Right? Then I would like to look at breadth. Right? How many products he is going to purchase? Right? So in fact, I will not use both of them. I will use only these three, the first three, R, F and M. Right? It's a widely used technique in most of the e-commerce, most of the consumer services and things like that. Right? Basically, if you look at customer service, in one case, we are working with one company where they are fielding the agents to serve the people. We are seeing that recency and frequency is one of the important metric they have to find rather than money, because anything that has recently happened and frequently happening, they're likely to have more problems with the gadgets they have at home. It can be, kind of a water purifier. It can be a fridge. It can be a AC. This company provides all of that. And we have found almost 60% of the problems are coming from only about 20% of the people. Frequently they will call, and really it is a problem. Right? It may be problem because of the product. It may be problem because of some other thing. But now we can predict who are likely to give more problems. So earlier they were doing it, okay, this is coming from this, but now we are establishing this as recency, frequency and cost analysis. So if you know this is going to come, why don't you change the product itself? Why are you going again and again and repairing it? That's not a good thing, right? So we would like to take these three and we would like to segment each of them, right? Let's read this. I would like to read, right? Let us take So we will use this code, we'll upload the data. We'll upload the data. Yeah, please. So now we will try to upload this data. Files is not there. That is surprising. Add some more code. Uploaded files upload. Okay, they're asking mount it on the drive. Let me mount it on the drive. I would like to see that I will upload the file. Right, I will upload this file. My file is RFMPT. RFMPT. Right, I will take this data. I will upload this. So where is my data? It's in drive. Okay, mount it. Content G drive.
It is just a file start up.
Sorry?
The collab.
Huh.
Just file start up.
No, it is not getting run. Is it able to run it? Files.upload. No, it is not working. It's not working for me. It says there is nothing called as files. Right? Files is undefined. Maybe you're using Collab.
I was
Okay, okay, okay. Let me check this. Okay. So none of them are working. Actually, what we would like to do is let me start my own thing. We spend more time on this than working.
Sometimes there's a need.
So what if instead of mounting it, we can fetch
No,
the
both
files
of them are
directly?
not working. I mean, neither the files upload or the mount is working. We'll see. I will try to open a local one. We can directly upload with the
Where is the data for us?
RFMPT dataset. It's there. It's there in your mail.
No, sir. That particular thing did come.
No attachment.
Is there?
There is one attachment.
Okay, sir.
Why we need to upload?
Because we want to use it in Collab. If you are doing it in local drive, you need not have to upload. You can just use pd.read_csv. Yeah, there is no need because I was using Collab. I had to use it. So let me start new one.
Yeah.
So let me use my use my code. Let us start with this. I would like to use all of them. I will rerun my code. I will not run cast. Let me directly go for k-means. I will go for k-means and I will remove cast. Okay, now we would like to run this. Get sample data. Okay, we got the data. Now we will go for clustering. Right, k is equal to 3 clustering. Okay, it's been done. Now we would like to look at showing clusters. Right, this is what we had. Right, now we are the k-means. Now I would like to read, right, customer segmentation. Read the data. So my df is equal to pd, import pandas as pd. Import pandas. Right, I would like to say df is equal to pd dot data frame e rfmpt dot csv. Sorry. Header is invalid. Okay. Okay, now we will see df head. So we can see some of the data. So I don't need customer ID because customer ID is an identifier. I cannot use it anywhere. Right. I don't need tenure, breadth and other things. Let me check the columns. So df columns. Right. These are the columns. I'm interested in only these three: recency, frequency and monetary value. Let me take it. This will be RFM variables is equal to this. Right, this is my RFM variables. Now my df1 df rfm is equal to df rfm variables. So I will take only this and I will check what is my RFM data looks like with RFM head. So it contains only recency, frequency and monetary value. Right, now I would like to get the values of this into a matrix. Right, my x becomes my x is equal to df rfm values. So this is my x. Now I can print my x. This is my x. Right, I have my x. Now I would like to call my k-means. Right, before that I would like to plot right? I would like to plot this, how it looks like, right? Let me plot this and see how it looks like. So I will add this. Okay, converting string to float. Which is the string? Okay, let me see. Can we plot df or fm dot? Right now we can see the frequency and monetary are taking over everything. Now we would like to go for scatter. Right, plot scatter. Directory of df or fm, how it looks like. So there are 3 variables and it contains multiple values. Okay, so box plot, scatter plot, scatter is not there. Let us look at the plot. So I would like to go for RFM plot. Plot contains these things. What are the plots? Density, scatter. Okay, scatter is there. So we will go for df RFM plot, scatter plot, just scatter. Right, what are the variables? Variables will be recency. How it looks like? Recency capital R. Recency. That. Just check that. Probably it may be due to the fact that it will be taken as string. Yes, it is object data type. It is not.
There are many missing values now.
That's okay. Missing values we can skip. That's not a problem.
That's the reason that it's creating.
No, no, no. All of this is taken as string. It is telling it cannot convert string. Okay, okay, okay. Though not these are missing values because of this. So actual data has been taken as string. So you have to remove them and you have to save them. Save as e rfm dot csv. This is my rfm. We'll go back and we will check whether you can take it. It's not RFM, it is RFM CSV, not RFM PT, it is just RFM. We will take this, we'll see tenure breadth and all those things, columns, reasons, monetary, TFM, RFM values, right? Okay, now we can see more or less all of them look like this when I take frequency versus recency, right? All of them are recent, but there is nothing I can see in terms of frequency, whether they are 400 months days old, 600 days old, 800 days old. I'm not getting any of them. It is not correlated with frequency, right? Now let us see whether the same thing can be tested for monetary, right? We would like to see monetary versus frequency. Monetary versus frequency. Now if we look at it, there is a very possibility whenever the frequency changes, monetary also changes. Let us change this a little bit. Let us put this on x-axis, y-axis, and then we'll put this on frequency on x-axis and the monetary value on y-axis. Now let us see how it looks like. Now it looks like whenever the frequency changes, most likely the monetary value also changes. Right, obviously, when you purchase more, when the purchase increases, the value of purchase also increases. The cumulative value of purchase also increases. Right, it's a natural one. So I would like to take only up to here. These are all outliers. I do not want to handle them because I may have to drop. In this case, I won't drop. Now using this, possibly this is one segment I'm looking at. This another. This another. Let us see how the segment turns out to be. Right, we would like to take this. Now we would like to plot, right, how it looks like, right, without clustering how it looks like, and with clustering how it looks like, right. So this is how it looks like, some 2 blah 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 and things like that. Right now I would like to change this because M is also there, M is selected, nothing is there. Now I would like to start with without my cluster how it looks like. Without clustering it looks like this. Now I would like to do the clustering. Without clustering, it looks like this. My recency versus frequency, right? Now I would like to change a little bit. I would like to say this is 1 and this is 2. Right, this is one of the reasons which I never liked Python, because why you want to make it so complicated when a easier way of doing it is here. For example, this is the easier way of doing it. Very intuitive. Right, rather than accessing the indices and then trying to give it, it is better you can directly give it, right? But people like it anyway, you cannot escape. So now we have this 1 and 2. This 1 is frequency, 2 is monetary value. How it is changing? So now it is changing. Now I would like to see where are my clusters. So let us take this clustering. We will do clustering now, right? Clustering has been done. I would like to call my k-means. I would like to take k and I would like to add it here and build the k-means. Right, k-means has been done. We will get that. Right, now we got the k-means. Right, now I would like to plot both of them. How my k-means looks like or how my clusters look like. Scatter plot. Right, with clusters how it looks like. With clusters how it looks like. This is with clusters how it looks like. Actually, it's a industry grade data because it contains about 100,000 customers plus, right, which is good. So now it is trying to plot all of them, right? Instead of R, let me put it as 1 and 2. It has put that, but I'm not getting where it is putting 1 and 2. Because let us see only here, right? This will be 1 and 2. Oh, it is only 1,30,000. You have more? Okay. So yeah, it is not.
Number of 5 lakhs.
Oh, M1 and M2, it is not giving M. Now let us look at whether it is giving M and R. So let us check that. So not a number. We have to check where exactly it has gone wrong. So that's one thing. Okay, let me check this once because I have not worked it out before coming here. Right, we have to fix this. Anyway, I'll fix this. Right, this is one of the problems that we can solve, which is nothing but a customer segmentation. The paper for this, you can read it as customer segmentation with RFM. Customer segmentation with RFM. Look at research files.
So how will be selected
Where?
from the data?
Okay. M is not coming because already when I call the K means, it gives me M and R. So M and R is coming from my K means here. I called M based on this. After executing this, I got M. Right? So invalid encountering true divide. The problem is here. So it is trying to divide by 0 and it is not happening. The error comes here. We have to fix that. So if it is something like that, then we have to fix it.
Cluster centroids, right?
Cluster centroids.
Okay, but initially also we need to send to this K means, right?
No,
that K.
Internally it will take that, right? Internally it will take select randomly. All those things will be done. So it randomly selects it, and then at the end it sends me M and R.
What is the input to this K means?
K means is X.
And what is K?
X we are not sent rest of the values. Maybe that is the reason. Maximum iteration. K is equal to 3. Just we are sent blah 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 and it was
K
not.
Is the number of.
Yes. We just called here with K means, that's why it was not working. So K means maximum iteration equal to 20, beta is equal to 1. Beta is equal to 1. Not much, we have all of them. It should have been working. Let us see whether we get M. Yes, invalid value. We have to see where is that invalid value. It is not a number. Okay, it is still running. We will see. This is one of the problems. The second problem which we are interested in is basically what we call as, let me add these things. Right. So I will fix this and share with you. Then we will see. The next thing we are interested in is what is called as, now let us say that we have 2x plus 3y is equal to 10 and 3y plus 2x is equal to 10. Right? Now I don't know whether I can solve this. Right? 3 pens and 2 pencils cost you 10 rupees and 3 pencils and 2 pens will cost you 10 rupees. What is the cost of 1 pen and 1 pencil? Right? This is a typical problem that will be given to us, which is nothing but solving the linear equations. They are linearly additive and we would like to solve these linear equations. Now if you see this, I would like to make this as probably I would like to multiply this by 3, this by 2 because the property is not changing. Right? So if I do that, this becomes 6x plus 18y is equal to 30 and 3x plus 2y, right? 6x plus 4y, 9y, not 18y, 4y is equal to 20. So it means that 6x will get cancelled and we will have 5y is equal to 10. So y is equal to 2. This is one solution. Right? Similarly, I will try to take 2x plus 3 into 2 is equal to 10. My 2x is equal to 10 minus 6 is equal to 4. My x is equal to 2. This solves the whole problem. Now, what is the way in which we can solve this? Right? How can we solve this? If we can give this as 2, 3, 3, 2 as one matrix and x, y as another matrix is equal to 10, 10 as another matrix. 2 by 2 multiplied by 2 by 1 gives us 2 by 1. Isn't it?
Yes.
2 by 2, 2 by 1 will gives us 2 by 1. I got the 2 by 1 matrix.
Sir, but that is 1 by 2, right?
Which one?
X and Y.
This is 2 columns and it depends. You can take it as 2 by 1 or 1 by 2, right? So you can multiply this. You can, right? One of the problem is we have to just transpose it and multiply, right? Just we have to see. That's why we don't do anything by looking at it. Rather, we will give it to the NumPy to solve all these problems. But the idea is that if you can have this, can I solve this problem? How can I solve this problem? If I take this, how can I solve this problem? One of the ways to do that is, can I make this as V1, V2, 0 and V3? Can I make this equal to some value N1, N2? If you make this, what is V3 is equal to N2? Right? Now, with all the multiplication here, it will be equal to N2 because if I multiply N1 into 0 plus N1 into N2 into V2, right? If I transpose it, N1 and N2, if I transpose it and start multiplying it, right? Either I can do this or I can go for multiply this with this, because one of the thing is if I take this, I have to go in this route. So it will be like this, multiplication will be like this. Rather, if I have this, right? One of the thing is I can go with this. I will transpose this and I will try to work with this. So one of it I can do. Now if I do, is there a possibility from this I can take V3 is equal to N2 and V1, right? Plus actually this will be V2, and if I take this value V1 N1 plus V2 V1 plus V2 is equal to N1. So in this case already I know V2, which is V2. Substitute this, V1 is equal to N minus 1 V1, and this is called as the backward elimination. I will start with eliminating backwards. This is what I am trying as forward elimination. I will go forward and eliminate it. The other way is backward elimination. So how can we use backward elimination? For this we need what is called as this, and this is called as upper triangular matrix. Upper triangular matrix basically is any matrix, any value below the diagonal is 0. All elements below the diagonal will be 0. Right? Some of the elements or all the elements above the diagonal are non-zero. It need not have to be 0. Or it, because that's just very easy. 0, 0, 0, 0 is a 0 matrix. It's not a upper diagonal matrix. Right? So the other possibility is lower diagonal matrix. Now if you take L dot U, you will get A. A matrix can be decomposed into its lower matrix and upper matrix, and it can be combined with product, dot product, you will get back A. And this type of thing is called as decomposition. Decomposition is very, very important when we try to do singular value or PCA and things like that. So one of the important transformations we had to understand is decomposition, right? This is not a basic thing, but it is second level. First level is transpose, inverse, determinant, dot product, matrix product. That's the first level. This is the second level thing. Can we decompose a given matrix into lower triangular matrix and upper triangular matrix? Right? And this is called as LU decomposition, and you can use it directly from any of the SciPy, NumPy, linear algebra libraries. Right? You can use SciPy linal, right? Or you can use NumPy linal. In that we get the lower and upper decomposition. So once we get this, the idea is, can we reconstruct this? First is this, next is this. Take A, decompose it to L and U. Given L and U, reconstruct A and check whether the same thing is happening everywhere. So now let us look at that. What exactly is what we are speaking, right? Now let's look at, let's take this array. So what we are doing is 1, 2, 3, 4, 5, 6, 7, 8, 9 is the array A that we are taking. We try to get that, right? Then we will take a LU decomposition from SciPy linear algorithms. It can be NumPy linear algorithms also. And when you do this, it will give three things: P, L, and U. To connect these two, because there is a possibility that when a 3 by 3 matrix is decomposed, it may not be decomposed into another 3 by 3, 3 by 3. Need not have to be. So normally we try to have an intermediate matrix between L and U. So it sends you back P matrix, L matrix, and U matrix. Now you can see what is P matrix, what is L matrix, and what is U matrix. Next time when this PLU is given, if I can do in this way, P dot L dot U, I must get A. So like this. So now I have this. If I want to make sure, I would like to get it as A is equal to P dot L dot U. So in Python terms, it is P dot L dot U. So when you transform, I don't call it as T. It is not transpose, it is transform. When you transform, it will give you PLU. When you do inverse transform, it will give A. So this is one of the transformations which is the earliest transformation that's available. If the matrix is small, if the matrix is square, then we can go for this. Otherwise, we go for pseudo transforms, because sometimes we get rectangular ones. Right, need not have to be square. It doesn't mean that a 10 million or 1 million record will contain 1 million columns. That is not possible. 1 million records may contain, like in this case, 100,000 records will contain only 5 columns.
So how do we give the other?
Pseudo, we try to make it as 0, 0, 0, 0.
We simply make them a 0 and then
sparse matrix and implement them. Right, we are not dealing with that. We delegate it to SciPy. But that's how it will be dealt.
But conceptually still works. You fill them all with zeros and then you take the upper.
Normally it will be sparse matrix computation. We don't do the way we did. It will be done as dictionary based, not as matrix based, as a column based thing. Right? Now let us look at how it works. Now I have taken L and I will execute this. When I execute this, I am getting PLU. Let us print P. Right? P is, if you look at it, 0, 1, 0, 0, 0, 0, all diagonals are zeros. Right? Now let us look at L. P.
What is P called?
P is basically a connective matrix. It connects connective. Yeah. Right? So L, if we look at L, all the elements above this diagonal, 1, 1, 1, above this diagonal, all the values are 0. It means that L is a lower triangular matrix of A. Right? Now let us look at U. U, if you look at it, all lower triangular things are 0. Right? Because of that, this will become an upper triangular matrix. Right? Now we have the connective matrix, the upper triangular matrix and lower triangular matrix. Let us connect them. I will take it as A reverse or A reconstructed is P dot L dot U, P dot L dot U. Because A can be decomposed into P, which is a connective matrix, L and U. Right? So now we execute it. And you can see 1, 2, 3, 4, 5, 6, 7, 8, 9. I can deconstruct it, I can reconstruct it. That's one of the things that we have to practice and see. Any deconstruction, I mean any decomposition for that matter, you can deconstruct it and reconstruct it.
So there are hand calculation methods of how do we arrive at a triangle or a triangle, those calculations.
Is there? I will share that with you. The PowerPoint is there. Right. It's not of much use to us.
Just trying to get into
Oh, you can. In fact, most of the PU textbooks, especially Schwarm series, will give you all this with 3 by 3 matrix, how to decompose LU, QR, Cholesky decomposition. I think you had this numerical methods in fifth semester. Same thing, nothing different.
If you open actually upper triangle, right triangle in the Google, it says by use course class first view maths and like it.
It is.
It's a question. The tool is having all this in the matrix formula. Now for 10 by 10, 3 by 3, something like that, we can imagine, this is upper triangle, lower triangle. But actually, in the huge, those millions of records, you still do the same.
Yes.
You really cut a line
Yes.
or 5,000 records.
Yes. Normally, when we try to do it, we don't do it across records. We try to do it across columns.
But still, so many.
That's okay. Number of columns is limited, right? Unlike rows, the columns will be less.
But there is no other method like, okay, some hierarchical that will not work in matrix.
That's why we'll go for distributed linear algebra also. There is a package called as Samsara.
Okay.
So that deals with linear algebra on Hadoop, on Spark. So if you look at petrochemicals and others, the number of variables, that number of columns that you have to work with will be in the range of 10,000 to around 2 lakhs.
Okay.
So 2 lakh by 2 lakh matrix has to be computed. That's the only way.
Does it really scale?
Oh, absolutely scales. Absolutely scales. Especially if you go for sparse matrix operations, absolutely scales. There is no problem. So most of the neural networks are implemented, tensors are implemented as these type of linear algebra methods only. There is no other method. But one thing they have added is differential programming. So you need not have to take difference between two variables. If you say layer 1, layer 2, automatically it gives the differentiation. So that's an advantage with TensorFlow, PyTorch and other things, which we don't find in scikit-learn.
So handling this matrix and arriving at all this inverse transpose, recomputation is the core computational work.
Core computational work if you are going for development of libraries in companies like that. So you have to choose whether you becoming a application oriented engineer or algorithm oriented engineer.
My question is for the resources, this becomes the main load actually. The computation has to.
Yes, it is memory intensive.
That's where.
Yes.
That is the cost of demand for the resource.
Yes. That's why the deep learning has got a larger carbon footprint. So that's one of the reason we are telling go for extreme learning machines, not deep learning machines. Because it is invented by Chinese, they don't like it.
Okay. So there is something like extreme learning.
Yeah, there is what is called as deep extreme learning machine, which says that whether you compute everything with differential programming and randomly assign and optimize it later, they are same. Right, when we take up neural network, we will see what he meant by that. He says that it is super fast learner and we demonstrate it is solving only linear regression what we solve. You need not have to worry about too many things. Right, because US always has got that upper hand, whatever they say we have to listen, but for us anything that works is okay. Whether Chinese, Korean or Malaysian doesn't matter, right? So enmity is there, but not on the knowledge. Any knowledge coming from anywhere is good. Yeah. So the next decomposition is called as the QR decomposition. It is very simple. It is Q and R. So A is decomposed into just Q and R. Q and R, and it can be Q dot R will give us A. Right. So QR decomposition is a improvement over LU decomposition, because when you do LU decomposition, it is necessary that we have to find the determinant. So determinant is nothing but if we take this, let us say, which is if we take this 1 into 5 into 9 45 minus 8 into 6 48, right? That will be minus 3. Minus 3 plus of minus 2 into 4 into 9 minus 7 into 6. Like that, we would like to find the determinant. Divide every element by determinant. Right? It's a tedious process if you want to go for LU decomposition. QR decomposition is much easier one, where they try to go for column rearrangement and row rearrangement. So because of that, normally when we try to do, we get similar one. I'm not changing here 1, 2, 3, 4, 5, 6, 7, 8, 9. But I would like to find the Q matrix and R matrix. So if you find Q matrix and R matrix, right now you can see I will remove this. Right now I'm going for Q matrix. Right now I will add it here. So I got this. Now I will add a part of code print Q. Print matrix is right now this becomes my Q matrix. Neither it is upper triangular, lower triangular. Right. So though they try to give me some meaning to Q and R, simply you can take Q and R. It is decomposed. Right. So once we do this, we can go for another code to understand what is R. Print R matrix is R. So this is R matrix. Right now we would like to go for some kind of, this looks like lower triangular, but it is not.
Yeah, that was the
Right, that's okay. Right now I would like to recreate both of them. Now reconstruct it. Right, reconstruct. Now I would like to do this. I would like to call it as AR is equal to Q dot R. Right, print reconstructed AR. Now we can see my reconstructed matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. There are other methods of decomposition, but more or less everybody is going with the QR based decomposition. There is what is called as Cholsky decomposition, which is coming from France, and there is Jaccadian decomposition. Right. All those plenty of decomposition methods are available. But mostly in distributed things, this is easier to implement because it takes only 2 matrices rather than 3 matrices. Right, because of that, most of the distributed elements like Spark and others have implemented only QR. So QR can be used in multiple ways. To understand where we would like to use, we would like to understand what is meant by eigenvalues and eigenvectors. So one of the things that we have to understand is basically an eigenvalue, which is nothing but if I take anything, right, there is what is called as an eigenvalue. Eigen basically means representative. Right, what is the representative value? And that is always a kind of, if you look at it, a scalar matrix or a row matrix. Right, subsequently eigenvectors are like this. Now what I would like to do is, once I get all of these things, I can use my Q and R to get the diagonal values and get the inverse of matrix, and that's how we would like to do. So the idea is, instead of getting all these things, that just get the eigenvectors. Right, eigenvectors will be used in computing singular value decomposition. We will see what is singular value decomposition. Basically it tries to say that these 3 values are really representative of your vectors, the constant values, and multiplied by this with some other modifications, you will get all of the vector. You can reconstruct it. So the way to do that is like we are telling here, right, we can just get the eigenvector. So same thing, I will not change anything here. Now what I would like to do is, I would like to find what is my eigenvector and eigenvalues. So 1, 2, 3 is my original one. Eigenvalues will be this and eigenvector is this. Right, now I would like to reconstruct. To reconstruct, I will take the Q, I will take the R. Right, basically now if you look at it, this is the QR matrix, which we QR decomposition which we did. The QR is basically inverse of Q. Whatever I seen earlier in the QR decomposition, Q is inverse of R is inverse of Q. Right, we can assign the vectors that is given here to Q and take the inverse of it, that becomes R. Right, then I will construct a diagonal matrix with values, the eigenvalues. right? Eigenvalues are coming here, and I would like to create the matrix like this. Now let us look at all this, right? I would like to take this now. I've computed this. Let us go for adding new code. Right now I will take this, add it here. Right now I would like to go for just get this, right? How it looks like. Let us look at how it looks like. Print q vector is my q, right? My q vector looks like this, right? This is my q vector, right? Am I using this? Why I'm getting q vector here? Okay, so once I get the q vector, I would like to go for inverse of r or r vector. So I would like to add a code here, right? I would like to use Control V, right? Print r vector, print r vector. This is nothing but our QR decomposition. So I will get my r vector. Right now I have q vector. My q vector is like this, right? My r vector is like this. Now I would like to go for finding my diagonal matrix from the eigenvalues, right? So I will add it here, right? Then print diagonal matrix. Diagonal matrix L. Now you can see. Can you see the diagonal matrix? Right, 1, 1, 1. Whatever the value you had, rest of the things is kept as 0. So diagonal shows how many rows are there. How many rows are there in the diagonal? 3 rows are there. So 3 rows, right, will be filled with 0. Only diagonal will contain any value. So this is obtained by eigenvectors. Eigenvectors, values will constitute. This is the actual representation of original matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? That can be simply represented with this matrix, which is eigenvalue. Multiply this with eigenvector, we get the reconstruction. Now let us reconstruct it.
The eigenvectors, eigenvalues is
Yeah. Eigenvector is q vector.
Q vector.
Right? So now you just take this and reconstruct it. Reconstruct it. Let's call this as A reconstructed. I would like to give AR. Now we can see after reconstruction, it will be same 1, 2, 3, 4, 5, 6, 7, 8, 9. And most of the engineering applications we use eigenvectors. What we are looking at will be eigenvectors. What we'll be looking for stability is eigenvalues. Normally there will be some kind of limits. If you are using a spring mass system, right? Spring mass system is nothing but is your electrical circuit, right? Mass will be current, right? Your stress will be resistance, and the potential difference is your voltage, right? And similar thing you can take in fluid systems. So your stress is viscosity, and the density is basically mass, and the flow is basically velocity or the current. So any system you will have eigenvectors. So eigenvectors will contain some value which can be used for writing other algorithms. So one of the other algorithms which we are interested in is called as principal component analysis. So basically, if you look at principal component analysis, what we are trying to do is we have some data here. I will do it for 2 dimensions, then it can be extended to n dimensions, right? So what we are trying to do here is we will take a vector kind of thing. Now it will be like this, it will be like this, it will be like this, right? When I have F1, F2 and F3 acting on this, if you take F1, right? F1 will have horizontal component which is F1 cos theta, sin theta, right? This is basically cos theta, right? This is cos theta, and this is F1 sin theta. right? There will be F1 sin theta and there will be F1 cos theta. Similarly, F2, F1 cos theta and F2 sin theta will be there. Because the angle here is 0, sin 0 is 0. There is no vertical component. Sin 0 is 0, F2 into sin theta is 0. Cos 0 is 1. Horizontal component will be F2 into cos 0, which is F2, right? So if you look at it, this will contain F1 cos theta, F2 cos theta, F2 will contain F2 cos theta, F2 cos 0 and F2 sin 0. So this is nothing but 0, this is nothing but F2, right? Similarly, we have F3. You can take this as, right, F3 sin theta or cos theta and F3 sin theta, though it is negative, it is coming down, right? Now if we see, if we combine these two, what we have here is F1 sin theta 1, right? And we have F3 sin theta 3 and we have F2 sin theta 2, which is 0, right? On the horizontal side, we have F1 cos theta 1 plus F2 cos theta 2, which is equal to F2 plus F3 cos theta 3, isn't it? What we have done, force coming in any direction, right? We are trying to decompose into vertical and horizontal components and try to align them. Now you have only two factors. The factor 1 is F1 sin theta 1. So we have F1 sin theta 1 plus F3 sin theta 3 is one factor. F1 cos theta 1 plus F2 cos theta 2, which is F2 plus F3 cos theta 3 is second factor. Earlier, the effect of this could have been felt here, could have been felt here. Now, when I decompose this, can the effect of this felt here? Impossible. You cannot feel it because this is trying to pull you up. This has no effect on horizontal movement. This has no effect on the vertical movement. So what we have done, we have removed the correlation effect. In this case, this is correlated with this is correlated with this, isn't it? This is correlated with this, right? By a factor of cos theta. This is correlated with this with a factor of sin theta. Now, is this has any correlation? No, no correlation at all. Right? Now, if you take 90, right? There is no effect. So whenever a set of components become orthogonal, the effect will not be there. The correlation effect is not there because they will be moving along this direction, not somewhere here, here, here and all. They are not scattered. If they are scattered, it will be like this, right? It will be like this. Now what you have done, you removed all scatter effects and try to move it in only 2 directions, 3 directions, 4 directions, which are orthogonal to each other. The moment you do that, you reduce what is called as the variance. The idea is now, let us say that I have this data point. Now let us have the axis here. This is the axis. This is x1 axis and this is x2 axis. What is variance? Variance is nothing but maximum minus minimum. Right? When we take variance, the variance will be this much. right? Now the variance across x1 is this much. This is x2v, this is x1v. Variance of x1 and variance of x2. Can you see this? The maximum difference between this and the maximum difference between this is the variance that we are getting. Now let us see that I will move this in this direction. The x1 is moved by some angle. This is called as rotation. I will hold it here. I will rotate this axis. When I rotate this axis, my x2 is reduced, isn't it? Now earlier it was here and here. Now it is only narrow band. And this explains more than earlier what it was. When I reduce the variance, I know what is the band. And that will be done by rotating the axis. That will be done by rotating the axis. With respect to this axis, I will rotate this force. I am trying to get this horizontal and vertical components. Similarly, if x1 and x2 is given to me, I rotate the axis and I will try to make sure that all alignment will happen only in few axes, which are perpendicular to each other. So there is no correlation effect. Normally what happens, this is called as PC1 and this is called as PC2. So this becomes your x2v, right? This becomes your PC2. And these are called as principal components. How do you compute them? Your PC1 is part of x1 and x2. A1 into x1 plus A2 into x2. Remember this? F1 into cos theta, F1 into sin theta. Right? Your PC2 is also B1 x1 plus B2 x2. Right? So now once we get this, all of this, x1, x2, all those things can be dropped. We don't need them anymore, right? We are explaining only for two variables. It can be done for n number of variables. How many principal components are possible? As many number of variables. If there are two components, two variables, there are two components. If there are 10 variables, there are 10 principal components.
They will all be orthogonal.
All of them will be perpendicular to each other. That is the assumption. In an n-dimensional space, you can have as many dimensions, as many planes perpendicular to each other. Only in 3 dimensions, 3 are perpendicular to each other. In n dimension, n are perpendicular to each other.
By definition, the principal components are orthogonal to each other.
They are orthogonal to each other. All principal components are orthogonal to each other. When they are orthogonal, the effect is reduced. At the same time, x1 could have could have given 10% of information. Now PC1 will give you 70% of information. If you want to reconstruct, you can reconstruct much better than with just x1. So it serves two purposes. The first purpose is stock market index. How about Sensex? How Sensex is found? It is nothing but a principal component analysis. Right? Normally index will be created as principal. For example, now we are computing what is called as quality of hire index. Right? Now if you look at the quality of hire index, it contains few components. So quality of hire index, right, is a function of PC a function of, right? So this will be aging or what we call as tenure, how long he has been with me, right? Performance, cost, right? ELTV, employee lifetime value. Using these four, I would like to compute quality of hire for every person. If I can find what is the quality of hire index, right? Normally we set the index to be 100 to start with. 100 is the lowest, which is not good. It should be increasing, right? What is Sensex now? Sensex is about 52,000 now. At some point of time, 2 years back, it was 17,000. If we had invested in 17,000, now it would have been tripled. Right? Same idea. If you can improve your quality of hire index, You will have more people who are staying with you, whose performance is very good, whose total cost of ownership is less. So how do you get that? That's another application of PCA. Will it be 100% correct? No. No, it will not explain your quality of air 100%. It will explain it by 70%.
How is it actually the index is formed?
Normally, over the period of years, you will take over the period of years, you will take 30 stock, 50 stocks, things like that.
Okay.
Right? At every point, you will try to find the PC. PC at T, PC at T1, T2 like this. PC at T1 will be taken as 100. Over a period of time, it might have jumped. In fact, it started with 1000. Now it is at 52,000. It is increasing. That is good.
So it's not simply average of all the stocks
No.
over time.
No.
Okay.
No.
Okay.
Or you can test it. It will never become 52,000. Average of all the stocks. It is index. It is a dimensionless number. There is no dimension for index. It's simply number. This is decided based on the initial value at this point of time, 10 years back, right? I will take it as index 100, right? Over a period of time, I apply the same formula. This is stock 1, stock 2, stock 3. It is changing. Some of them may come down, some may go up, some may be out of the thing. I will reintroduce something else. Now, once I compute the principal component, we would like to attach for first principal component 100. Subsequently, is it changing or not? We would like to check that. And this is a transformation. If this is 100, what this will be? So this is nothing but if my principal component can explain 70% and its value is 100, now it can explain 75%, what will be its value? Right? For 1% it will be 100 by 70. For this, it will be 100 by 70 into 75. Right? This is T1, this is T2. Simply similar calculation will be computed for T3, T4, T5, T6, T7. For a period of time, we compute this and this will be our number. So let us say that this is somewhere around 100 divided by 70. This will be 1 point for all practical purposes. Let's keep it as 1.4. Now, this will be more than that, right? So we would like to see how exactly this is changing over a period of time. And this will be because we would like to understand what is the base value from which they are taking. I'm just taking 100, but you have to keep some base value.
So what is the principal component analysis actually doing over there?
Principal component analysis is trying to combine the weightage of each of them, A1, A2, A3 for stock 1, stock 2, stock 3. The value of Infosys is 100,000 rupees. The value of another stock is 1,500. Right? What is the weightage should be given to Infosys? What is the weightage given to Wipro? What is the weightage given to Reliance? What is the weightage given to ONGC? That will be done by principal component analysis.
Then you can easily predict what.
It is not predicting. PCA is only a transformation. What is likely to happen will be done either with neural networks or with regression and things like that. So there are two things that you may likely to do. One is prediction of the direction of the stock movement, whether it moves up, whether it stays there only, whether it comes down. These are the three possibilities. It is range bound, it is positive, it is negative. Depending on your risk appetite, you will tell if it is more than 2%, it is up. If it is less than 2%, it is down. If it is between -2 and +2%, it is normal. It is moving up and down. Now in next 5 weeks, is it moving up by 2%, moving down by 2% or not?
So, just again, the focus of PCA, not understanding. Then, so you're saying if since it is showing 1,000, so that 1,000 to 2,000 it has moved, the variance, 70% of that is probably explained by Infosys stock, and 30%
Yes.
is
Yes.
10% is by somewhere else, somewhere else, somewhere else. So that is the over a period of time, that is the data it has captured and does the PCA analysis.
PCA.
Tomorrow, you can say if the stock market fell down by 500 points.
Who is driving that down?
You can pretty much expect that Infosys stock would have fallen by so much.
Not necessary. It may be Infosys, it may be some other stock. Whichever is fallen, that's why weight will come down.
But it is the total of all this.
Total of all this, but each of the individual ones are the shackles that are pulling down that stock.
Okay.
So this coefficient will tell you what is the weightage for that stock.
Okay.
Right. Normally what we try to do is take first 5 in the PC1 and invest there.
So let us say if the first one had 50% of the weightage and then rest all of them have 50% of another weightage, then the stock is going and up and down. So then this
that's unlikely.
I
mean,
just to understand the context
Yeah.
perspective. So this fellow may be contributing a lot, the big fellow.
Absolutely. That's why we are very careful. In fact, when PCA does it does it over a period of time. That heavier one, you have to see their investment. They will not change more than 1%. Unlike others which are 10x, 20x, they will not change by not even 1%.
Okay.
So whether gain or loss, it will be less than 1%. Otherwise, there will be bloodbath in the market. If let us say that Reliance falls, India lost almost for 10%. ONGC falls, another 10% gone. So because they are not investing in alternative energy, but Jio is good. Reliance is investing in wind, solar and other things because they are planning that in few years they would like to provide only the green energy with hydrogen and all those things. They do not want to import oil. Even if they import oil, it is to provide it to Germany. Take it from Russia, give it to Germany.
Okay.
Right. The strategy is good, but the idea is that heavier the weightage here, lesser the volatility. Right. Anybody who is heavy, they cannot dance easily. Yes, bank can dance easily. All of a sudden it becomes 150, all of a sudden it becomes 15. Infosys cannot happen like that. If it has to happen, it happens over a period of months, 3 months, 6 months, 1 year like that. By that time, people will be out. Normally, we say that if the loss is more than 5%, drop and come out. Right? Minimize your losses. Come out quickly. Infosys doesn't matter. We are not Warren Buffett's.
This one side question on that. Are the people who are mathematically following the stock market using this PCA and all, are they really successful?
Absolutely. You can look at a fund called as Renaissance Fund.
Okay.
They are using neural networks and other things for last 30 years. They can beat hell out of anybody. Right, but nobody wants to tell because if they tell, the advantage is lost, the edge is lost.
Right.
So they say no, neural networks will not work, machine learning will not work. Even true also, it works only with the data you select. All are good. In financial analytics, we say that don't speak, make money. Don't tell anybody. Why you want to tell this works, that works and all? That will be only academicians who do. Now the benchmark is if you are getting 24%, you are good. Because it is 400 times more than what bank gives as 6% interest on your FD. So if you can do that, you're good. You don't need anything. Whether you do it with AI, do it with something else, do. But don't lose the principle. You cannot say in one I got 90%, in another I got minus 90%. No. Don't lose the principle. Get 24%. If you are doing it, good. If you are not doing it, you have to be there. Certainly machine learning helps. If somebody says they are not able to do that, they are using wrong methods. It is impossible for machine learning not to learn the pattern. So you have to read behavioral finance. If you are planning, even because for everybody, my suggestion is always if you are learning AI or machine learning or data science, spend 10% on financial analytics. You invest your money and make money there. That's very important. Otherwise, you can speak, you can write papers and all those things. It is teethless tiger. Right. So it will not eat anybody. It cannot do anything. Right. So minimum is 12% because you must be twice the bank interest that is being paid, which is much easier if you use ML methods. There are groups who are doing that, but there are quacks also because people will go with hype. I will use AI. You give me 10,000, I will teach you. No, you should risk your money and you should work there. You should do paperwork and come here. All of the methods what we are doing. Out of them, the neural networks are one of the best. For short-term trading, long-term trading, no, still it is fundamentals. But short-term trading, swing trading, within 3 months, if you want to do something, nothing beats neural networks. If people are telling otherwise, they don't know or they do not want you to know. One of the two. Right, though I cannot reveal more than that, certainly work on it, I guarantee you, because I am getting it. You should do. Don't mean we are not greedy, just to show that your machine learning works. Right, what you're, because in nowhere else you can demonstrate your capabilities. There you are putting your money and you are showing your capabilities, people trust you. Right, especially when you show your tax receipt. Right, this is what I paid for my returns. I mean, this is what I got. Nobody can deny. Right, because you'll be paying 15% for 3 months. Yeah, go for PCA. Right, normally we'll come back to this. Probably it takes some more time. We are running out of time. We will continue this in next session. We will try to get into details of PCA. Then we will go for singular value decomposition. Right, both of them are there with you. We will see how we can do this. Yeah. Okay, team online. We'll connect again next week. Right, hope you'll be presenting the assignment. Right, maybe 5 minutes each. If we are done that, please share it quickly so that any changes that is needed, I can give the feedback. You can submit it. Yeah. So, but make it.
The first assignment.
Yes, first assignment with rank order clustering for any one of the case you are selected.
That time is.
Yes. Yes. Yeah.
So we want to submit what will be the exam pattern for this?
Exam pattern will be about 30% will be some kind of theory. You have to explain any of the methods, k-means or matrix transpose and things like that. What is the theory behind that? What is the algorithm that you are using? How do you implement it? That theory, all of that is open book exam. You need not have to worry about it. The second thing is how do you implement any one of them to solve the problem? Right, it can be PCA, it can be k-means, it can be SVD, it can be neural network. Right, there will be one of the code which you can use the code and you have to solve the problem, not write that, because code is already available to you. Right, like the problem we saw today. Right, one of the problem was the data was still object. Right, and there was something which was missing and it was giving NAN. But I would like to make sure that you will get a small data set, not with 100,000. Right, idea is to apply it. Can you apply it? If you can apply it, because it is not available anywhere on the Google. All the codes are available with you. What you had to think how you should use that. Right, what is the inference that you are getting? Yeah. Okay, catch you later.
Thank you, sir.
Thank you, sir. Bye.